Today we're going to be covering chapter 11.3, which is the addition formula. Okay, though this formula is given inside the formula sheet as well, I just want you all to remember some things before you all use the formula. So for example, let me go through the addition formula for sine A plus B. So basically this is a trigonometric identity. So identity means that the left hand side, okay, is equivalent to the right hand side. So these terms on the right hand side is equivalent to the terms on the left hand side. So it's a means by which we can express the sum of two angles, the sine, cosine and tangent of the sum or the difference between two angles in this form itself. There are various reasons why we may want to do so. For example, we may want to use special angles, so to speak, but not to worry. I'll actually show you how all of this is done, right, with a few examples. But just to pay attention, okay, in case you look at this and go, whoa, what's this? Okay, for sine A plus B, sine, usually the plus and minus will follow. What do I mean by it will follow? For example here, okay, if you look at this formula here, sine, okay, of angle A plus angle B equals to sine A cosine B. Then here's a plus, here will also be a plus, cosine A and sine B. Similarly, if I have sine A minus B is sine A multiplied to cosine B minus, it follows this guy here, cosine A and sine B. So be careful, it's sine, cosine, cosine, sine, okay? Just follow the formula, you'll be fine. For cosine itself, the formula is actually flipped in the sense that this is plus and minus, this is minus and plus. What this implies is cosine of angle A plus angle B is equals to cosine A multiplied to the product of and has product with cosine B minus, notice that this is a plus, this symbol here is a minus, sine A and sine B. Okay, similarly, cosine A minus B. This is cosine A, cosine B. Instead of, now this is minus, this will be a plus, sine A and sine B. Alright, so just be very careful, okay, the symbols are a bit small, so you may actually miss this out, okay, for sine and cosine itself. I'll now go through a few examples on how we may actually apply these angles. So let's start with example 10. So example 10, using cosine A minus B, okay, they usually give the formula, find the exact value of cosine 15 itself. Notice that we do not have any special angles with cosine 15. What are special angles that we know? 30, 45 and 60. Okay, there is no 15 degrees. So now, if I want to find cosine of 15 degrees, the first thing I can do is this. How do I get 15? Okay, I know you tell me 5 plus 10, but in terms of special angles, 30, 45 and 60. If you can see, 45 and 30, if I take the difference of 45 degrees minus 30 degrees, what I'll get is 15 degrees. So that is what I will start with. So what I'll say is cosine of 45 minus 30. So I'm using special angles here. I know you can say that 60 minus 45, that works as well. But please don't use things like 75 minus 60, because even though I know the ratio for cosine of 60, which is a half, I do not know what is cosine of 75 or sine 75 for that matter. Hence, I choose to use 45 minus 30. If you want, you can actually try to use 60 minus 45. You actually get the same answer itself. But for today, I'll use cosine 45 minus 30. I apply the formula cosine A multiplied to cosine B, then minus, then here's a plus, sine A, which is sine of 45 degrees, and sine B, which is 30 degrees. I'm just applying the formula. Then all that's left to do is to remember our special angles. Cosine of 45 is square root 2 over 2. Cosine of 30, square root 3 over 2. Plus sine of 45, square root 2 over 2. And sine of 30 is half. If I simplify everything, I will get root 6 over 4 plus root 2 over 4. So if I combine the fraction, I will get root 6 plus root 2 over 4. And that is a simpler application of how I can use the addition formula itself. Okay, example 11. It's given that sine A is equals to 12 over 13, tangent B is 3/4, pi over 2, A is greater than pi over 2 and lesser than pi. Okay, pi over 2 is 90 degrees, pi is 180 degrees. So this implies that this angle A actually lies in the second quadrant. So second quadrant, we know that only sine is positive, but tangent and cosine itself will be negative. So be very careful here. So I will just write here, only sine is positive. Similarly, for this, okay, you notice that this is 180 degrees to 270 degrees. So this is actually in the third quadrant itself. So I can say is angle B lies in the third quadrant. Okay, in the third quadrant, AST, only tangent is positive. So before you even start the problem, you can write all of this down in pencil, okay, at the side there. It will help you so that later you'll be very clear about what you're doing. Okay, now, so for the first one, since only sine is positive, what I'm going to do is I'm going to draw the diagram here for this angle, for angle A itself. So for angle A itself, this is angle A. So sine of angle A is 12 over 13. So this is the reference angle. 12 over 13. Opposite over hypotenuse, 12. This is 13. So if I were to apply Pythagoras' theorem, I take 13 square minus 12 square. I square root it. I will get 5. Since this is negative here, so this will be negative 5. So this is a representation for angle A. We just do that for angle A. Now we will do it for angle B. For angle B, it is said, okay, so angle B is in the third quadrant, like this. Okay, so this is angle B. Alright, but I will remove the angle B first, and then I'm going to do this. It is tangent B is 3 over 4. So tangent B is 3 over 4. So this is the reference angle for the third quadrant. Tangent B, okay, so 3 over 4. Opposite over adjacent. Opposite is 3. Adjacent is 4. If I apply Pythagoras' theorem, 3 square plus 4 square square root, what I'll get is this length here is 5. So I know this is for tangent B itself. Okay, so if you just want to make it more accurate, this is negative 4, this is actually negative 3, so that you won't get confused later when you need to find the values of sine, cosine, whatsoever. So now what I'm going to do is I'm going to find the exact value of sine A plus B. Okay, so sine of A plus B, if you refer to your, what I call your formula sheet, what you get is sine A cosine B, then plus cosine A and sine B. So what is sine A? If we look from here, sine A is from this triangle, opposite over hypotenuse. So sine A is 12 over 13. Second quadrant, sine is positive. We check positive, no problem. Then the next one is cosine of B. Cosine of B comes from this diagram here. So cosine of B itself will be with reference to this triangle here, adjacent over hypotenuse. Adjacent is negative 4, hypotenuse is 5. Hence, cosine of B is negative 4 over 5. Plus cosine of A. Cosine of A, I go back here again. Adjacent over hypotenuse from this triangle, adjacent is -5, the hypotenuse is 13. So cosine of A actually gives me -5 over 13. This is, then we check, we think a while, second quadrant, only sign is positive. I got a negative value for cosine of A. It means that this is actually correct. Sine of B comes from this diagram again. So sine of B, sine is opposite over hypotenuse. So opposite is -3, hypotenuse is 5. So what I get here is -3 over 5. Then I think a while, third quadrant, only tangent is positive. Sine of B comes out to be -3 over 5, all good. So eventually what I can do here is this. If I use my calculator, I calculate, I'll find that the exact value of sine A plus B is -33 over 65. Okay, please attempt try 10, okay, and then I will actually pause the video, attempt try 10, and then I will go through it in a few moments. Okay, in 3, 2, 1. Okay, for try 10 itself, using cosine A plus B, find the exact value of 75 degrees. So 75 degrees, the special angles we have are 30, 45, and 60. So 75, very clearly, it is 45 plus 30 degrees. So what I'll get is, I'll let A be 45 and B be 30. I apply cosine A plus B is cosine A, cosine B, minus sine A, sine B. You need to remember all these special angles. Cosine 45 is √2 over 2, cosine 30, sine 45, and sine 30 itself. Then let me just help you a bit here with the simplification. So what I get is √6 over 2, √6 over 4, minus √2 over 4. You combine the fraction, you get √6 minus √2 over 4. Okay, please pause the video now and attempt try 11. When you're done, I will go through the answer with you in 3, 2, 1. Let's go. Okay, first and foremost, what you need to be able to do is this. So if you notice here, this angle A is in the third quadrant, and angle B itself, 90 to 180, is in the second quadrant. So you need to place these angles correctly first. So let's start with sine of A first. It's given that for cosine of A is given to be 3 over 5. Okay, so 3 over 5 is in the third, not the third quadrant, my error there. Cosine of A should lie in the fourth quadrant itself. So what we do is cosine. Okay, so this is the reference angle here. So it actually goes this way. And then what I do know is that my cosine of A is adjacent over hypotenuse. So 3 over 5. So you use Pythagoras theorem, 5 square minus 3 square square root, you get 4. However, this length here, it lies below, okay, on the Cartesian plane. This is -4. Hence, I will label this side here as -4. Similarly, for B itself, B is in the second quadrant itself. Second quadrant, and what they actually tell you is that tangent B is -√3. So tangent B is negative of √3. So actually they have labeled this wrongly. This is B. So opposite over adjacent. So opposite is √3 over adjacent is 1. So they said that tangent B is -√3. So actually I'll label here as √3 and here as 1 first. Then there's a negative sign there. So I noticed that because this goes backwards, it's like negative. Okay, so this would be -1. So that when I solve, okay, I will say, or when I read the triangle, tangent B opposite over adjacent, so it's negative of √3. once again, what I will do is I will apply Pythagoras theorem. C square equals to A square plus B square. So 2 square equals, so A square plus B square, you square root, okay, you will get this answer here as 2. So now what we'll do is this, using those triangles there, I will need to solve sine A minus B, sine A cosine B, cosine A sine B. Okay, so now sine A and cosine B, cosine A sine B. Sine A is simple enough, -4 of then I will also need cosine of A. So for me to get cosine of A, okay, it is adjacent, which is 3, over hypotenuse is 5. Notice that my cosine ratio is positive, and hey, it's in the 4th quadrant, positive cosine A is correct. Similarly, if I want to get my cosine of B, okay, so my cosine of B, adjacent over hypotenuse, and so from here, this triangle, cosine of B, adjacent, -1, hypotenuse is 2. Hence, cosine of B is -half. Sine of B, opposite over hypotenuse, √3/2. Notice that I actually get a positive ratio, and it is correct because in the 2nd quadrant, sine is positive. I plug all of those values into my formula. I will get 4 minus 3√3/10. Okay, example 12, okay, deals with what I call the solving the equation. So now, let me solve example 12 with all of you. So now, what I'll do here is this. I get cosine of theta plus 30 degrees equals to sine theta. Notice there's nothing I can do now. So what I can do is apply the addition formula. So I get cosine minus sine and sine equals to sine of theta. And then what I can do is this, cosine of 30, 0, 30. So this term, the first term becomes square root 3/2 cosine of theta. Cosine 30 becomes √3/2 minus sine of 30 sine of theta. Sine of 30 is half, so I get half sine theta equals to sine theta. Then what I can do is I start to collect terms. So square root 3/2 cosine theta, half plus 1 gives you 3/2 sine theta. Then I will divide both sides of my equation by cosine theta and cosine theta. So sine theta over cosine theta gives you tangent theta. And cosine theta over cosine theta is simply equals to 1. I start to rearrange my equation. I will get tangent theta is equals to square root 3/3. So we know that tangent theta is positive. If tangent theta is positive, it will either lie in the 1st quadrant, A, S, T, or it will lie in the 3rd quadrant, like this. So I find that my reference angle, alpha, is equals to 30 degrees. Hence, the theta value I have is 30, or the theta value I have is 180 plus 30 is equals to 210 degrees. Okay, please attempt try 12, okay, and then I will go through the answers with you in a short moment. Okay, let me make the thing bigger. So it's in 3, 2, 1. Let's go. Okay, for try 12, again, we will start to apply the what I call addition formula. In this case, sine A minus B is sine A, cosine B minus cosine A and sine of B, which is the equivalent down here, is equals to cosine X. Then what I can do here is this, sine of 30 degrees is half, okay, cosine of 30 degrees is square root 3 over 2. I start to rearrange, collect the terms, half cosine x, and this cosine x will give you negative half cosine x, okay, and this root 3 over 2 sine x will be over here. How we get this portion here? We will divide by cosine x and divide by cosine x, and I achieve tangent x is negative 1 over root 3. So if you find negative 1 over root 3, your reference angle, if you press it in degree mode, you find that it's actually 30 degrees, or in radians, it's actually pi over 6 radians. Since my x value, okay, is my tangent is negative. Tangent is negative means that you appear in the second quadrant and the fourth quadrant. So if I quickly sketch here, second quadrant, A, S, T, and C, and my fourth quadrant. So I know that my alpha is pi over 6, my alpha is pi over 6. So what I'll get here is the first angle is 5 pi over 6, and my second angle is 2 pi minus pi over 6 is 11 pi over 6. So that is the answer for try 12. Now, for the addition formula itself, what I have is this. It will follow, so tangent A plus B. So let me say tangent A plus B equals to tangent A plus tangent B 1 minus tangent A tangent B. Be very careful about the symbols. Similarly, tangent A minus B is equals to tangent A minus tangent B, then 1 plus tangent A tangent B itself. Okay, so that's how this addition formula for tangent A plus B works. Okay, example 13, we are asked to prove the identity. So what I'll do here is this. I will start from the left hand side, or rather I'll start from the right hand side in this case. So from the right hand side, if I apply the what I call addition formula, so what I get is tangent A plus tangent B, then I get 1 minus tangent A tangent B. So tangent of 45 is actually equals to 1. It's a special angle. So, and over 1 minus 1 times tan x is tangent x. Straight away, it is shown. Okay, please attempt try 13. Okay, and actually the answer is there already. So, but do attempt tangent 13 by applying the what I call addition formula for the tangent, and this